In this video, we're going to take a look at how we can use MATLAB to not only find the equation of a tangent line, but also to graph the function as well as the tangent line on the same plot. So that way we can kind of see if truly it is a tangent line and kind of what effect it might have with respect to proximity to the tangent point of the function. And so we have this function, just as an example, we have this function e to the x sine x, and we want to consider what the tangent line is at the point x naught equals 0. And so what I did was I just drafted some code that would show you how to both find the equation of the tangent line and then also to plot the graph of the function as well as the tangent line on the same graph. So we do our sims variables and we do our f. I defined x naught to be 0 as a variable. And to get y naught, the y coordinate, I just plug x naught back into the variable x in the function f. All right, so basically in here, you're going to plug a 0 and a 0, and that's what this function does and assigns it to y0. Then we take the derivative, which helps us to find the slope. And the slope is going to be when we substitute x naught back into the derivative. So that's what this line does. Then we just pull a little bit of algebra magic. Remember, we have our formula y minus y1 equals mx minus x1. All I did was I just added y1, or in this case, y naught, to both sides. And I got the equation of the tangent line right here. So we have the slope, we have x naught, and we have y naught. So this just gives us y equals mx plus b, basically, sort of form. Then we plot the function and as well as the tangent line on the same graph. And so what I'll do is I'll kind of go through from scratch 2 other examples of being able to plot both the tangent line as well as the function and find the tangent line. Okay, so we have a polynomial function, real nice and easy one, cubic. And so we're going to start by taking some sims variables. So we're going to have sims x, f, and I'll just define deriv to be a symbolic variable again. And our function f is going to be x cubed plus 2 times x squared minus x minus 1. Then we're going to go ahead and just define x0, in this case, to be -1. I defined it to be -1 because, well, that's what it tells us to right here. And then I'm going to find y0 by substituting. Okay, so go back here. So y0 is going to be equal to subs. We're going to substitute back into f, the variable's x, and we're going to substitute x naught back in there. We're going to find the derivative so we can find the slope. So we're going to say deriv equals diff of f with respect to x. And now we can get our slope by substituting. So we're going to use the subs function. We're going to substitute in deriv. We're going to substitute for the old variable, which was x, and the new variable is x naught. And then now we're going to find the equation of the tangent line. So I'm just going to call it tan line, and that's going to be equal to the slope times x minus x naught for x0 plus y0. And now I can go ahead and graph. All right, so I'm going to do an easy plot, and I'm just going to easy plot f. Now I'm going to plot f. Our point is -1. All right, so we're really not concerned with too many other points other than what's going around -1. So I'm going to plot it from -2 to 0. All right, you don't have to put a domain in, but this might be beneficial for being able to view what's going on around that point. I'm going to turn the hold on, and I'm going to do an easy plot of the tangent line. And I'm going to do it at the exact same interval, 0 to -2. And I'm going to turn my hold off. All right, so, and then I noticed over here that I had the grid on. I'll do it with both grid on and grid off just to show you the difference. All right, we're going to go ahead and run. And it might just take a moment. All right. And so here is our equation, and here is our tangent line at the point -1. Now, of course, we could zoom in if we wanted to. So I'm just clicking on the graph, and I'm just zooming in by rolling my mouse over. And as we zoom in, the closer we get, we notice that it's precisely at the point -1. Okay, it looks like it's just touching there, which we should expect for a tangent line. All right. Now, let me go ahead and, by the way, here's the equation of the tangent line, negative 2x minus 1. Okay, it should be y equals negative 2x minus 1. But we can turn the grid on and go ahead and run it again. And we'll probably notice that it doesn't really make a significant difference here. Okay, so pretty cool that we can find the equation of the tangent line at precisely negative 1, and then also plot them both on the same graph. Now, once we have the code, the good news is that we can just change the input slightly to be able to get our second example completed. All right, so now we have this function sine x cos x at 5/4. Okay, so I'm just going to change my function to sine x times cos x. Remember, MATLAB, you have to make sure that you explicitly define multiplication. Our point is at pi/4. We're going to substitute x naught, so this just stays the same, this stays the same, this stays the same, this stays the same. So these are all generic commands, right? Because these are the parameters that are going to govern those commands, right? Now, the only thing I'm going to do is I'm just going to change the range. And we know that 5/4 is about 0.78 or something like that. So let's just go from 0 to 2. All right. And we're going to go ahead and plot. So let's run this. And here we go. We just get y equals a half. All right. Certainly it's tangent. All right. It's not really the most complicated of all the graphs or functions we could have, but certainly tangent at that point, right about here at y equals 0.5. So pretty cool. And the point, like we said, pi/4 is about 0.78. All right. So as we scroll in a little bit closer, we notice that the tangent line is right about maybe like here at 0.78, which is indeed about pi/4. All right, so pretty cool that we're able to find the equation of the tangent line, as well as graph the tangent line, as well as the function on the same graph to kind of get a visual as to how they work in tandem with one another.